Hello and welcome to this session. In this session, we are going to discuss the following question, and the question says that prove that R is a partial ordering relation on set A and then draw the Hayes diagram where the set A is equal to set containing elements 1, 2, 6, 12 and 24 and R is a set of all ordered pairs AB such that A divides B. We know that a relation R on a set S is called partial order if it is reflexive, that is, A is related to A for all A belonging to S. It is antisymmetric, that is, if A is related to B and B is related to A implies A is equal to B. And it is transitive, that is, if A is related to B and B is related to C, then A is related to C. With this key idea, let us proceed with the solution. We have to prove that the relation R equal to the set of all ordered pairs AB such that A divides P is a partial ordering relation on the set A equal to the set containing elements 1, 2, 6, 12 and 24. For this, we will prove that R is a relation, and to prove this we have to prove that it is reflexive, antisymmetric and transitive. First is reflexive, that is, A is related to A for all A belonging to set A. Here we will prove that element of set A divides itself. Here we have the set A is equal to the set containing elements 1, 2, 6, 12 and 24. So, clearly 1 divides 1, 2 divides 2, 6 divides 6, 12 divides 12 and 24 divides 24. So, all elements of A divide itself. So, we may write, let A belong to A, then A divides A for all A belonging to set A. So it is reflexive. Now we have to prove it is antisymmetric, that is, if A is related to B and B is related to A implies A is equal to B. Here we will prove that if two elements of set A divide each other, then they should be equal. In this set, we can see that 1 divides 2, but 2 does not divide 1. Similarly, 2 divides 6, but 6 does not divide 2. On comparing all the elements, we see that two numbers A and B in set A, which divide each other, are numbers itself. That is, if two numbers divide each other, then they are equal. Thus, two numbers in set A will divide each other, then they must be equal. So now we may write this as, let AB belong to the set A such that A divides B and B divides A, then A is equal to B. So it is antisymmetric. Now we shall prove that it is transitive, that is, let A, B, C belong to the set A such that A is related to B and B is related to C, then A is related to C. Let us choose A equal to 1, B equal to 2 and C equal to 6. We see that 1 divides 2, 2 divides 6 and then 1 divides 6. Similarly, if we take A equal to 2, B equal to 6 and C equal to 12, we see that 2 divides 6, 6 divides 12, then 2 divides 12. Thus we observe that for all A, B, C belonging to the set A such that A divides B and B divides C, then A divides C. So it is transitive. Now we will make its hash diagram. For this, we will first write all elements of R where A divides B for A, B belonging to set A. Here we have the set A equal to the set containing elements 1, 2, 6, 12 and 24. So we get the relation R is equal to the set containing elements or ordered pairs 1, 1, 2, 2, 6, 6, 12, 12, 24, 24, 1, 2, 1, 6, 1, 12, 1, 24, 2, 6, 2, 12, 2, 24, 6, 12, 6, 24 and 12, 24. Let us first draw its diagram showing all elements which represents reflexivity and transitivity by loops and arcs. We will get the following diagram. Now see, orange loops at the nodes indicate elements of reflexivity, that is 1, 1, 2, 2, 6, 6, 12, 12 and 24, 24. and the red arcs represent the elements of transitivity. Now to make his diagram, do not draw loops, do not draw arcs from A to C when there are arcs from A to B and B to C, which shows transitivity. Redraw so that edges are upwards. And lastly, remove arrows showing directions. So we first remove all the loops and red arcs from this graph and we are left with this graph. Now we redraw it with all edges in the upward direction and we get this graph. Now we remove all the directions. So this is the required haze diagram. This completes our session. Hope you enjoyed this session.